Hello everyone. In this lesson, let's take a look at reduceByKey. ReduceByKey is a function which, when called on a dataset or RDD of key value pairs, will return a new RDD also of key value pairs. However, in this new RDD, the values for each key in the original RDD are aggregated using the given reduce function, which must be of type double value returns one value. And this is a function that you're going to pass. So let's take a look at what the documentation will tell us in reference to reduceByKey. And if you look it up, this is what you will find. Now, don't be intimidated by this. We're going to break this down and make it simple. What you're looking at simply are three different usage options for reduceByKey. All of them do the reduceByKey functionality, but the second and the third do something a little extra. So before we get into all that, what I want to do is I want to separate the usage options. Let's move those up to the top, and let's take the definitions and condense them on the bottom and just look at whatever is common in all three use cases. And we'll come back to the remainder. So as you can see, we have moved the usage options up to the top. Let's leave those there for now. We're going to come back to those. Let's focus on the common areas of the definition. And the first sentence here that we're going to focus on is this: merge the values for each key using an associative and commutative reduce function. What does that mean? Well, this is actually really important, and associative and commutative, here is what it's talking about. It's a math term. But what this is really trying to tell us is that when we pass a function to reduceByKey, it should meet these requirements, because when this is ran on a cluster and we get returned back from different nodes, which may come to their conclusion a fraction of a second different timing than the next node over, you don't know which order your elements are going to come back in. So therefore, you must pass a function that meets these requirements, because what this makes it so is that the final outcome of your function should not depend ever on the order of the elements, because as you can see here, we can move the elements around in any which way. The outcome is always the same, and that's what that first sentence is talking about. Okay, so that's the first sentence. Let's take a look at the second sentence in the definition that is common across all three use cases. This one says that this will also perform the merging locally on each mapper before sending the results to a reducer, similarly to a combiner in MapReduce. What does that mean? In order to explain what this means, it's easiest to compare it to something that it is not. And for that purpose, what I'm going to do is I'm going to show you what GroupByKey does, and then I'm going to contrast that against what reduceByKey does. Now, GroupByKey is another function that's not what we're covering in this particular lesson, but I'm going to use it simply so that I can compare it to reduceByKey, okay? So here is GroupByKey. As you can see, GroupByKey, you have the top layer here, which is the mapper layer. We're going to call those three at the top the mappers, and then we're going to call the two at the bottom the reducers, or the reduce layer. So as you can see, for each key that the mappers have, they're going to send everything down to the reducers. It is a very expensive operation. It's a very expensive shuffle because it's network intensive. In this example, we're looking at 2 keys for A and 2 keys for B, so it looks simple, right? But in real life, A may be 30,000 or 30 million, who knows? So as you can see, the reducer layer, those nodes down there, they're catching everything for a particular key that from every node. So if you have a lot, then that's going to be a lot, and if you cannot fit that into memory, you're going to get an out of memory error. This is what GroupByKey does. It just sends it all down there for the same key, and that's why it's very expensive and should be avoided whenever possible. Here is, in contrast, what reduceByKey will do. Now, full disclosure, you'll notice that the final outcome is the same. However, how reduceByKey goes about making those calculations is very different, and here is why it's preferred over GroupByKey. What that last sentence means is that, as you can see here, for example, the mapper nodes on top, they have 2 elements for A1. They do a local reduce and make that into A2. So if that's 30,000 elements of A1, you'll get A30,000, right? So whatever it is. But the point being is that for each key, the mappers only send one element, which is the reduced value for each key down to the reducer nodes. And so you see the load on the reducers is much less. And that little shuffle there is a lot less expensive than the one that you do with GroupByKey. So this is why it is preferred to use reduceByKey whenever possible. And that's what that second sentence was talking about. Okay, now let's take a look at the use cases. And you'll notice that the top one here is the basic reduceByKey functionality. The other two simply add the reduceByKey functionality plus a little something else. In the second example here, you see num-partitions integer. That basically what it does is allows you to do the reduceByKey function and also designate the number of partitions of the resulting RDD. And the third and final use case is essentially the same thing. Do the reduceByKey functionality, but in this case, you are designating the partitioner that the resulting RDD is going to have. Those are the only differences. And of course, you'll see that this is very common with a lot of the API functions, that they have either one or three use cases, either the basic functionality or the additional functionality of being able to designate the partitions of the partitioner. So let's look at how it is used. Here are two examples that are correct of using reduceByKey. Now, you'll notice the one that we have been looking at always at the top. Most people in real life don't use that one because since this is the only real option that you have, the shorthand is what you most often see out in the field, which is basically telling Scala, here's the spot for one, here's the spot for the other. Just go with that. And it works. We're going to see this a moment after when we get onto the command line. And what this is telling reduceByKey is, hey, when you run into these two values, x and y, do this, x plus y. And it is implied in the bottom example. And of course, the sentence on the definition of this one that was not common in all three use cases is at the bottom, and it says the output will be hash partitioned with the existing partitioner and parallelism level. Of course, basically it's telling us that we're going to use the default values per partitions and partitioner because you didn't tell us what to do here. Okay, and that's obviously makes sense. The other two options, here they are. This is where you tell reduceByKey to use, for example, a partitions. Same thing. At the bottom, you have the differing sentence that the output will be hash partitions with the number of partitions that you just told it to do. That's what the difference is. And finally, the last usage option, you're telling it to use range partitioner. And this is the only way you're going to use this option because hash partitioner is the default. So you wouldn't tell it to use the default. It's going to use that anyway if you don't tell it anything. So by default, the only time that you will tell it to use partitioner is if you want to, for whatever reason, use the range partitioner. And those are the three usage options. So now that we have talked about that, let's just get down to what exactly does reduceByKey do with your data. What does it actually do? So for that, we have a starting RDD here on the left, and we have the resulting RDD on the right. You'll see that the starting RDD is made up of key value pairs. Each one of these keys represents a city. And of course, the value in each one, to make things simple, represents 1. So what if we pass this RDD to reduceByKey, the resulting RDD is going to be as follows. Boston showed up in the original RDD 3 times. And since the value for everything is 1, when you apply reduceByKey with x plus y, obviously the result is the key for Boston shows up once, and the value 1 plus 1 plus 1 equals 3. That's what you get. The same thing for New York. New York shows up 2 times. 1 plus 1 is 2. So New York City key is assigned the value of 2 in the resulting RDD. LA shows up 4 times in the starting RDD. As a result, in the end RDD, in the resulting RDD, you have the key LA once, and then the value is 1 plus 1 plus 1 plus 1, that equals 4. And that is essentially what reduceByKey will do. So let's take a look at what this looks like on the command line.